Okay. So here's the problem. You can, I mean, I don't care if you want to, you can watch or not watch. I'll do this, and if you want to see this, if that's great. If you want to keep working, that's great until you get to one you want to watch. So water's draining from the tank. The outflow is 8 cubic feet per second. And it tells that they want to know what's the rate of change of the water depth when the water is 4 feet deep. Okay. All right, so snapshots, what are we given?
Height of 15 feet. Radius.
Okay, true, but for like snapshot values of the quantities, that is important. But what are the snapshot values of the quantities that we're given here? So we got, we'll call this maybe, I don't know, what do we call the height of the water? We'll call that Y,
Sure.
and we'll call the radius R, I guess. Okay. So the height is 4, so we know Y equals 4, right? What else do we know about that?
V dot.
V dot equals,
8.
is it 8? Almost. Is the volume getting bigger or smaller?
Negative.
It should be negative 8, yes. Okay. And then we want to know Y dot, correct? And the rate of change of the water depth. Okay, the problem here with this one, and this is a good problem to look at because this is one where we start with 2 independent variables instead of 1. We know that the formula for the volume of a right circular cone is 1/3 pi r squared times h, which we're calling y, right? But we have an r in there, right? We'd rather not have that r in there. Because if I'm going to include the r, when I differentiate, I'm going to have r's and y's and r dots and y dots, and I don't have all that information, right? So what could we do instead here then? What could we do to eliminate a variable? Can we come up with a secondary equation that relates r and y so I can eliminate one? Yeah, there you go, right? Yeah, look, we know that these are similar triangles, aren't they? Right? So there's a triangle. Well, that's a pretty bad triangle. We get the idea. Those are similar triangles. And so they're proportional, right? So we know that 14/7 must be the ratio of the depth of the water to the radius of the cone of water, right? So y over r. And that's just equal to 2. So in other words, r equals y over 2, right? We agree? Okay, so I could take that secondary equation and make a substitution. It makes this problem a lot easier then, right? So we get v equals pi thirds times y over 2 squared. Wouldn't that just be y squared over 4 times y is y cubed over 4, so we end up with pi 12ths y cubed. That makes things a lot easier, doesn't it? Because now when I differentiate implicitly, look what happens. I just get v dot equals 3/12 is 1/4 y squared y dot. Now I can solve for y dot easily. Okay. So the moral of the story on this one is you always want to try to write this as a function of a single variable if possible. And in this case, the variable is y. Okay? You could do it the other way, but it's just a lot more work. I'm not sure if that's how they did it on this one or not. Is this the one?
They want H instead of
Okay, that's fine, but do they make you solve it in terms of like R dots and H dots?
We do 5 or 12 H squared H dot.
They do it that way, okay. That's a bad way to do it. But you can, so if you did it that way, if you went the route of having to plug in R dots and H dots and all that stuff, then what would I do? I could just go fill in some additional snapshot values, right? Because I know that R equals Y over two, right? So if Y is 4, then this is telling me that R equals 2, right? And if I were to differentiate implicitly here, wouldn't I just get R dot equals Y dot over 2, right? So I could make a substitution here if I wanted to. I could say that Y dot equals, or R dot equals Y over 2. So then I could, whatever, in my formula down here, when I'm getting to this point where I want to plug stuff in, I could just trade the R dots for Y dots and just solve for one thing. Right? It really, do you see that it really, this is a dumb way to do it though. It's so much easier just to do it this way. Yes, sir.
Also, wouldn't you get Y dot?
Mm-mm.
No?
No, the derivative of Y with respect to t is just Y dot.
Oh.
Now, if that were Y squared, then I'd have to use chain rule.
Oh, okay.
But this isn't a chain rule though. See what I'm saying?
Yeah.
Okay. I want to see what they ask you to do on this. So they want you to. Oh, no, they do it the right way.
Yeah.
They do it the right way. Yeah, they want you to write the equation that relates V and H. Yeah. That's good. So they did it the right way. Yeah. Okay. Okay, if you want to look at this, go ahead. You don't have to. Okay, so chi, Katie's flying chi, reaches a height of 53 feet, and then it just only moves horizontally, drifts due east. So our picture just looks like that, doesn't it? Where this is 53. And we'll call this X, how about, and we'll call that like Z. Okay? And that's a right triangle. So then what are the quantities we're given?
That's blowing at, so 3 feet per second.
Okay, what is that?
Right.
So that's going to be
X dot.
X dot, there you go. And
And then 11, 13.
so what's that going to
Z.
be? Z.
Okay.
Because that's the amount of string that's out, and then you want to know how fast is the string running through your hand, so what's that?
Z dot.
There you go. That's just Pythagorean theorem. So you guys take it from there.
Thank you.